You ever heard the expression, it's all fun until somebody divides by 0? It's a great math expression. I love it. So why do I say that? Well, because now we got to the algebra point of this. Okay, we don't have any more graphs. Nothing here, nothing there. Let's just go out and do this. Okay, so check this out. It's a rational function. Uh-oh. That means, guess what? Yeah, you can't have a denominator that's a non-permissible value. Uh-oh. Look, you got two non-permissible values here. So think about what the NPVs, non-permissible values, are. So you go x minus 1 cannot equal to 0, solve for x, x cannot equal to positive 1. There's one of your non-permissible values, which is eventually going to give you, yes, you guessed it, an asymptote. Oh, now you're remembering all of this. If you didn't, oh boy, go back to Math 20-1 because that's where it's at. Look at the other one. X minus 3 cannot also equal to 0 because you can't divide by 0. Bring the 3 over, x cannot equal to positive 3. So you actually have two asymptotes going in this particular graph. Now, so state the domains and ranges. Well, domains could be anything you want except x, such that x is an element of R, except x cannot equal to, yep, non-permissible values, 1 and 3. There you go. Boom. X can be anything else as long as it's not 1 or 3, because that's going to make this denominator 0, and dividing by 0 doesn't work. Okay, so let's now start talking. Let's start figuring things out. Look at this. I'm giving you a really kind of a funky equation here. I'm saying 3 times the value of f plus g at 2. So just do that. Go 3 times f at 2 plus g at 2. That's all it's asking you to do. So find me f of 2. Find me g of 2. Add them together, multiply by 3. That's as simple as that. Okay, so let's do exactly that. Let's take 2, put it in here. So you got 2 times 2, 2 minus 1. 2 times 2 is 4. 2 minus 1 is 1. 4 over 1 is just plain old 4. So this thing now is 4. Perfect. G of 2, throw it in there. This is going to be 2 over 2 minus 3. Right, so this 2 over minus 1, this is negative 2. Oh, how lovely. This is minus 2. Perfect. What's 4 plus a negative 2? 4 plus a negative 2, of course, is 2. Let's get rid of this. 4 plus a negative 2 is 2. So this equals to 3 times 2. 3 times 2 looks like 6 to me. There's your answer. And that's how you evaluate this kind of expression. All right, now check this out. Oh, this ought to be interesting. This one says, now, give me this expression in simplest form. Uh-oh, spaghetti-o, let's go figure that out. No. Okay, here we go. Let's go back to your original. Our originals are these two guys. So we're going to combine them. We're going to say f plus g, algebraic. Here we go. Ready? This is 2x over x minus 1 plus g of x, which is x minus 3. Now that's not in the simplest form, because remember what you can do with this. You can find the common denominator. Okay, so common denominator, x minus 3, common denominator, x minus 1, x minus 1. But you know what? I like leaving the denominator in factored form. Okay, so this is just going to be x minus 1, x minus 3. There's your factored form. Oh, how pretty. Let's do this one now. Distribute, distribute. I'm going to have 2x squared minus 6x. This, of course, is going to be distribute, distribute. This is going to be x squared plus x squared minus x. Let's combine like terms and let's find out what we got. Okay, perfect. 2x squared and x squared gives me 3x squared minus 6x minus x is going to give me minus 7x. Oh, how pretty. Now, we can complete this by factoring out an x here and just have an x, 3x minus 7 over x minus 1, x minus 3. And when we get into rational functions coming up in the future unit, you'll see why it's really important to put everything down in factored form. That's what it looks like. Got it? Okay, so look at the next question. The next question says the same thing, but evaluate this, or I should say, give me this as a subtraction now. Okay, well, that's easy enough. That's going to be 2x over x minus 1, subtract x over x minus 3. Same stuff as before. Exactly the same thing as before. All you want to do is find the common denominator. X minus 3, x minus 3, x minus 1, x minus 1. Yeah, there it is. Okay, here we go. Distribute. You still have your 2x squared minus 6x. Now, don't forget to distribute the negative, though. That's where I'm going to get you. Okay, so this is minus x squared plus x all over that common x minus 3, x minus 1. Okay, now put this all together, combine like terms. There we go. We have x squared, combine this term with this term, minus 5x all over x minus 3, x minus 1. Factor this guy out so it looks a little prettier. You got x minus 5 over x minus 3, x minus 1. Now, one of the things that I didn't do here is I didn't do the restrictions. But I know the restrictions are still based on those non-permissible values that I found earlier. So again, the restrictions are those non-permissible values that are in the denominator. And they were the same for this one and for this one here. So of course, x cannot equal to +1 and +3 because either one of those values will make that denominator 0 and you can't divide by 0.